Hello everyone. Today I'll be talking about hypothesis testing, a crucial method used in statistics to make decisions and draw conclusions from data. Let's dive into its meaning, purpose, and applications. Hypothesis testing was developed in the early 20th century primarily by Ronald Fisher, who introduced the concept of p-value to evaluate evidence. Later, Jerzy Neiman and Egon Pearson expanded the framework by formalizing the use of significance levels and statistical power. This method revolutionized how scientists and researchers draw conclusions from data, making it a cornerstone of modern statistics. So, what is hypothesis testing? Hypothesis testing is like a courtroom trial for data. We begin with a null hypothesis H naught, which assumes no significant effect or difference, and an alternative hypothesis H1, which contradicts H naught. Our goal is to use sample data to decide whether to reject or fail to reject the null hypothesis. Let's go over the process of hypothesis testing. The process involves 6 steps. First, we define our hypothesis. Then, we choose a significance level such as 5% to determine the threshold for rejecting the null hypothesis. Then, we analyze the data and calculate a test statistic. Finally, we compare this with a critical value or p-value to make a decision. Now, let's go over the few key terms that we saw just now. The significance level. The significance level denoted by alpha is our threshold for deciding whether to reject the null hypothesis. The p-value. The p-value is like a statistical gatekeeper. It tells us how likely it is to observe our data, or something more extreme, assuming the null hypothesis is true. If this value is smaller than our predetermined threshold, which we often take as 0.05, we say, okay, the evidence is strong enough and we reject the null hypothesis. The next is the test statistic. The test statistic is like the strength of the signal in our data. It summarizes how far the sample statistic, like the mean, is from the null hypothesis is from what the null hypothesis predicts in terms of standard error. The larger the test statistic, the stronger the signal against the null hypothesis. Here are a few other key important terms that we use in hypothesis testing. We will now walk through an example to understand hypothesis testing. Imagine a pharmaceutical company claims their new drugs lowers the blood pressure. Our task is to test this claim statistically. The null hypothesis denoted by H naught assumes the drug has no effect, meaning the average reduction in blood pressure is zero. On the other hand, the alternative hypothesis H1 claims that the drug does lower blood pressure, with a mean reduction greater than zero. To test this, we collect data from a sample of 10 patients who took the drug and recorded the reduction in their blood pressures. Here is the data. We will now analyze this data to determine whether we have enough evidence to reject the null hypothesis. To do this, we perform some simple calculations. We first calculate the sample mean. We then find out the standard deviation. For simplicity of calculation, we assume it's 1.5. We then perform a one sample t-test to find the t-value. We use the given formula to find the t-value, which comes out to be 11.4. To decide whether to reject the null hypothesis, we compare the t-value to the critical value from the t-distribution table. For a one-tailed test with a significance level of 0.05 and 9 degrees of freedom, the critical t-value is about 1.833. Since our calculated t-value 11.4 is much greater than 1.8, we reject the null hypothesis. This result means we have sufficient statistical evidence to conclude that the drug significantly lowers blood pressure. This illustrates how hypothesis testing enables us to validate claims with data and statistical reasoning. Now, let's see the applications of hypothesis testing apart from data science. Hypothesis testing is widely used across fields: in medicine to verify drug efficacy, in business for A/B testing, in engineering for quality assurance, and in social sciences to analyze the survey results. Its versatility makes it invaluable for data-driven decisions. In summary, hypothesis testing provides a structured approach to decision making in the face of uncertainty. By carefully analyzing data and interpreting results, we can make informed and reliable conclusions. Thank you for listening.